Hey, good morning, and today we'll still continue with the OOP review. Hopefully we can go as far as I really plan to, but we'll see. If you got questions, as ever, just stop me whenever anything that's not clear. Reminder about what you should be watch out for. So your Lab 0 Part 2 is going to be due this Friday, 12 noon, the same deadline, the same time. Make sure you submit in time. And for sure, for Lab 0 Part 2, you have to watch out for the tutorial videos and also the PDFs, especially the second one. It's about a programming pattern, right? So you have to make sure you understand how to use the primitive array of some reference type. For example, you may have maybe products array, right? Some variable here, and you have to have an integer counter. For example, number of products, right? That's something you really have to study in detail. That's really the essence for part 2 of your tutorial. You're going to apply that pattern there for all the subsequent labs and also for your programming test. I cannot emphasize enough. So where do you find the PDF? Just go to the lab instruction and also the study site. The PDF has been there since day 1. And unfortunately, my Thursday office hour this week will have to be rescheduled. I just have some conflict. So what I will do instead, I will try to shift that hour to sometime on Friday instead, maybe over Zoom. So if you want to speak to me, so please either today, tomorrow in the scheduled live session, I will be there, or maybe a Friday over Zoom. I'm going to announce this more officially to choose the time. Right? So, but if you want to speak to me, that should be still no problem at all. All right, before we move on to the topic, let's have a quick recap about what we did last time, very quickly. So last time, we basically started talking about how you can create objects, right, using the new keyword. And we talked about how you can use the computer memory to understand about reference variables, right, storing addresses as opposed to just primitive value, right? Make sure you have that clarification. And we talk about the idea about variable shadowing, right? In order to break through the variable shadowing, if you got the parameter name clashing with the attribute name, you have to use the this keyword. That's how we fix it, right? You got to use the this dot, right? That's also something we spent quite a bit of time explaining. Make sure you review it. If you got any trouble understanding it, reach out. And we talk about this efficient way of tracing your OO code. We're going to apply this technique throughout the course. So we're going to do a lot today as well. So just make sure you understand the convention here. Do you really have to follow that 100%? I would say maybe not, but it's really the simplest one I can think of to really help you trace. If you really want to follow your own convention, be my guest, as long as you can get the tracing right. It's up to you. Okay? I wouldn't force you on that. But this is really a nice way to trace. And talking about the this keyword, and we talk about how you can break down the object creation, right? Part 1, part 2, and part 3. And we talk about how you can trace accessor versus mutator, right? And we talk about this tracing of the code. And we're going to do something way more complicated today, involving arrays. And we talk about how you can make use of an accessor versus mutator, right? We talk about different cases. Make sure to review them. And finally, we talk about method parameters, right? What will be the design principle in general? I would say whatever principles you learned about from the slides or from what I say in the class, try to apply them in your lab. If sometimes you find that maybe the way you apply is not exactly the same as what I taught in the class, just reach out. Maybe there's some compromise you have to make. It's always the case. Principle is just principle. You always have to adapt a little bit. And this is where we kind of left off, right? We talk about primitive versus reference values, right? About this example here. Take a look. And the last one that we talked about was this example. We only did it halfway. So we're going to continue from there. So what we did last time was we talked about primitive values. This example is meant to prepare you for the next one, which will involve primitive array of reference types. Let's continue with this example to finish that. We got I1, I2, I3, right? So these are the 3 boxes over here. And we got the first primitive array of size 1, 2, and 3. So that's why we got indices 0, 1, and 2. Storing I1, which is 1, I2, which is 2, and etc. That's how we figure out numbers 1 array, right? That's how you visualize it. You're going to need it. And for this line here, we basically creating another array called numbers 2. It's pointing to the beginning of some consecutive blocks for the array, for the storage. And this one here, it's some array of length corresponding to the length of numbers 1. Because numbers 1 here of length will be 1, 2, and 3. So this one here should be 1, 2, and 3. Except that the values should be just default values. We haven't changed them just yet. Any question until what I have said now? Any question? Anything that's not clear to you? It might be now time to really ask before we go a little bit deeper. Yes?
Why number 2 is set to the default, not the one?
Yes. So the question was, why were these values over here simply default values? It's because if you compare this one and this one here, right? This one here, we're basically following this array notation here. We say, for index 0, give me this value. For index 1, assign to this value, right? But on this notation here, we're basically saying, just create a new array object for me. Whatever value is supposed to be stored there, for now, just default values. I can reassign them later. Yeah. All right, let's move on. What we want to trace right now is this for loop over here. All right? We want to know, after this particular for loop, how are we supposed to change the layout, the contents of these two arrays? And how do you trace the for loop? The way I do it, you have to first of all figure out how many iterations there are. So question number 1 for you guys. In order to run this for loop, how many iterations do we have? How many? 3? Okay, that's good. To be more precise, first iteration I is going to be of value 0. And then second iteration, I++, I will be 1, and then I will be 2, right? Etc. Let's now sketch this out. So we're going to have first iteration, and also second iteration. And also we got third iteration, right? For the first iteration, I is simply just going to be 0. And at the end of the first iteration, I++. So for the second iteration, I is going to be 1. And for third iteration, I is going to be 2. At the end of the third iteration, I will be incremented to 3. Agree? Now, is this condition over here going to be true or false? False, right? Just be careful. I'll write it down for you. Right, it's a review, from the first year, right? Just about how you trace the loop. So when I is equal to 2, you want to think about after I++, I will be equal to 3. And if you think about this condition over here, as soon as this condition becomes false, we're going to exit from the loop, right? Numbers 1.length, I less than, I'll just say n1, numbers 1.length. Right? In this case, I will be 3. Numbers 1.length, 1, 2, 3, will be 3. 3 less than 3 will be false. Right? That's how you figure out the logic, right? Any question until now? I'm just let's sketch out how the structure of the loop is going to be executed. And then we're going to go in to see how to execute each iteration. Iteration number 1. For each iteration, we're going to do this. Okay, iteration number 1. I'll just say n2 for numbers 2. Numbers 2 at index I, which will be 0, is assigned to numbers 1 at index 0. Do you agree? Right? I'm talking about this line here. And for this line here, between the iterations, I will be instantiated to the current value, 0, 1, or 2. For the first iteration, this is what we're going to do. And how would that change our diagram? We want to assign whatever value that's stored in n1 0, which is here. Assign that to n2 0, which is over here. So the way to do that would be, we want to say rather than 0, it's going to be 1. Guys, are we good? It's not too bad, huh? Okay. If you're really struggling, feel free to ask me to repeat. Okay? I assume everybody's okay. All right, for second iteration, it's going to be something very similar, but except that we're going to say n2 at index 1, because now we're talking about I being equal to 1. It's assigned to n2 at index 1, right? So that means this part here, rather than 0, is going to assign to this value, 2. Let's finish that. The third iteration, n2 at index 2, is assigned to n2 at index, n1. Beg your pardon. And I definitely make a typo here. I really meant to say n1 here. n1 at index 2, right? You can see that here we got 0, 1, and 2, just corresponding to the value of I over here, right? And the third iteration is just going to make a final modification. So this one here is going to be this value, 3. Okay? So this will be the outcome after executing the entire for loop. Whenever you see a for loop, I would say it will be the easier case for you to trace. You will have to, number one, figure out the number of iterations you're going to run. Number two, for each iteration, you may have to apply the loop counter value to different places. For example, here, we are replacing the loop counter I by the specific value for each iteration. All right, after this, let's now do one more line. The line I want to do is here. All right? It says that numbers 1 at index 0 should be assigned to 4. Numbers 1 at index 0 should be assigned to 4. All right? Easy. And now you can easily figure out the output from there, right? What will be numbers 1 at index 0? 4. What will be numbers 2 at index 0? 1. Okay? If you think that's easy, good sign. The way I'm going to set up the reference aliasing example in the next page will be similar loop structure. But since it's going to involve reference type, meaning that it's going to involve reference aliasing, things will be a little bit different, but not too much different. Any questions before I move on to the next page? Yes, please.
So for the condition of the loop, because we have like a small matrix, it's easy to trace and figure out.
Yes, yes.
What if we have like thousands of pointers?
Well, I would say it's a good question. The question was, here it would be easy to trace the array. For example, the array is only of length 3 over here. So what about in some cases where you may have to trace an array of size maybe 1,000? I would say typically you don't really have to go for this big. The reason that we are trying to trace, either because we want to understand our code better, or number two, we want to debug the code. We want to find out the error. And for either purpose, usually you want to start with something small. You don't want to start with something very big. In order for us to understand our code, usually array size up to 5 should be enough for us to figure out the behavior. So you shouldn't really have to go for up to 1,000. You shouldn't have to. Mm-hmm.
So for testing, it should be like small.
Yeah, I think, no, we'll put it this way. Let's say you want to test the correctness of this particular code. You should really start with maybe array of very small size, maybe empty array, make sure it works, the base case. And you want to start with, you want to go on to array of size 1, size 2, size 3, maybe up to size 5 or even 10. If all of them work, there's a good chance your code is correct. Yeah. Of course, later on you can even try maybe 1,000. Presumably the test case is going to pass without you having to trace. That's usually the pattern. Start with something simple and move all the way to something more complicated. It's a good question. So, yeah, guys, in case you missed what I just said, what I just described is more like a testing strategy. Whenever you want to test your piece of code that you wrote, start with some simple test case with small input in order for you to trace. If you start with something too big, it's unrealistic. You're giving yourself a hard time unnecessarily. Okay. All right, let's now move on to the next example. And I would suggest if you have a piece of paper or you got something to write on, grab it and let's do this together. Okay. So why don't we start with this? I'm going to present this maybe block by block, just for block number 1. Let's say after executing these 4 lines, how should you draw the diagram? Why don't you take 1 minute and to visualize it? And for now, you can assume for each person objects, you have 2 attributes, name and the age. That's the assumption we are making. All right? What's going to happen after these 4 lines? Meanwhile, I'm going to draw on my iPad page, and I will turn. Take 1 minute and draw it. All right, another 30 seconds. So this would be very nice practice, right? So let's say you're given a piece of code of similar complexity. That's what you basically have to do in the test or in the exam. Okay, I'm almost done myself, but you can try to practice. Okay, another maybe 10 seconds before I turn the page. Funny enough, the first 4 lines might take the most drawing. Once we reach the subsequent lines, it's mainly just redirecting the arrows. All right? All right, let's now take a look. This should be more or less what you will get. So what we have done, 1, 2, 3, and 4, right? Let's take a look. Alan should be pointing to a person object with Alan, and the age in the beginning just default value. We're assuming that the constructor doesn't initialize the age just yet. So let's say put 0 here. Similarly, we got another object here, Mark, pointing to another person object with Mark name, different objects, right? And also Tom and Jim, similar, right? Tom and Jim, just pointing to different person objects. And for now, the ages are all just 0, default values. All right, any question about the first block? We good? All right. And let me go back to the slides. What I would like you to draw now is the next block. How about this one here? How would you extend your diagram in such a way that it's going to have this array called persons1? And somehow the persons1 will get connected to Alan, Mark, and Tom. All right, take 30 seconds to draw. Whenever you want to visualize an array, ask yourself the first question: how long should the array be, right? Okay, another 10 seconds. Okay, take a look. All right, so the line I'm talking about right now is this line here, the orange one. So persons1 is pointing to the beginning of an array. How long? 3, because we got 1, 2, and 3. All right, and now let me put a little bit more explanation for you. What we used to do is, if you recall what we did earlier, we said when we execute this line over here, we simply copy I1 value here into over here. That's what we did earlier. Now, are we copying primitive value anymore? Not really. We're copying address. Right? So the way to think about this is like this. I'm going to write it down. So think about this one. Put a star here. All right? Put a star here, and this can be understood as the following. Let's say you already created, you can think about this is like this. We first of all try to create a person array. I'll just say P1, just to save my writing, equal to new 1, 2, and 3, right? Person 3. Because we know we need to put 3 addresses in. And then, individually, Alan will be stored at index 0, Mark will be stored at index 1 and index 2. So, the subsequent 3 lines goes like this. P1 at index 0 should be assigned to Alan. P1 at index 1 should be assigned to Mark. And P1 at index 2 should be assigned to Tom. And let me move the array a little bit down so you don't really get too confused. Oops, sorry. Sorry about that. Let me just go back there. There we go. So I want to move this away a little bit, like that. 1, 2, and 3, and 4. So the orange line over here, you can think about behind the scene, is really executing 1, 2, 3, and 4. That's my point. Okay? And in the beginning, after this line here, P1, every slot over here is going to store what? 0 or what? Null, because now we talk about reference type, so the default value should be null, right? In the beginning, right? I'm not going to draw it, okay? But how about this line here? How do we understand this line? Let's just do the first one. P1, 0 is referring to this particular slot over here. We want to store something in it. What we want to store is whatever Alan is storing. Alan is storing the address of this particular object. So we are basically copying the address of this object here, Alan, into the first slot, index 0, into here. Now, how do we draw the diagram accordingly? Should I draw something like this? Doesn't quite make sense because the object itself doesn't store an address. So what you should really do instead is like this. Here is going to point to where Alan is pointing to. I'll pause a little bit, make sure I understand the first line. It is so fundamental. If you get lost, raise your hand. Don't be shy. Get lost. Okay, no worries. Maybe you're raising hand for other classmates too, right? So I'm glad you do that. Okay, let's start from the beginning. We are talking about this line over here, right? Okay, make it bigger. This line here. We're saying the following. We are storing this value here into index 0 of P1. But now we are talking about saving address. Whatever address that is stored in Alan, we're going to copy the address and store that into index 0 of array P1. That's what we're doing. Diagrammatically, when you say, I want to store the address that's stored in Alan, basically I'm saying whatever Alan is pointing to. If I want to store that address into P1 at index 0, I'm saying now persons 1, rather than default value null, is now going to point to wherever Alan is pointing to. That's what we're doing. Right? So I would say you want to understand this in two angles. Angle number 1, understand that you are copying address 1 into a slot. Number 2, diagrammatically, you're letting this guy here to point to wherever this guy is pointing to. Two things. Well, if you just say system out of print line, just persons 1, of course, you only print out the address for the array. But if you try to maybe dig deeper into what's really index 0, it's going to tell you, yes, it's Alan here. Okay. Let me show to you. So at this point, let's say this. How about I put a star over here, right? Let's say right after this. If I say, I'll say S out for system out of print line. How about I just print? Sorry. If I say print P1 at index 0, right? What should it print out? Should it be null or some address? Should be some address, right? Which address should it correspond to? The address of this object here, right? So this one here, I'll just say address of Alan. Of course, try it out in Eclipse. On the other hand, if I say, let me just do one more just for completeness. Okay, let me move them a little bit, if I may. If I try to say print P1 at index 1, What would that be at this point? No, right? It's still the default value, okay? Hopefully that kind of clarify stuff a little bit further. But these two only correspond to, these two here only correspond to right after this assignment. But if we try to do two more, this may not be null anymore, all right? All right, let's now finish that. What about this one here? So P1 at index 1 should point to wherever Mark is pointing to. And Mark is pointing to this object here, right? So what we should do is, you should now point to Mark. And the third one here, P1 at index 2, over here, should point to wherever Tom is pointing to. So it should point to here. All right, are we good? Okay. We're getting somewhere, but we haven't even executed the loop yet, but we'll do that. All right. Okay, so let's now move on. What I want you to now consider would be, let's say green. Can you please try to trace 1, 2, and 3? Based on our knowledge from how to trace a for loop from the previous example, this one should be not too bad. We already prepare you for the algorithmic complexity of the method here. All right, that's what I would like you to do. All right, let me now switch to the slides. You can take a look. I will say give you 2 minutes to see how to do that. So now what you want to trace will be from line number 6 to line number 8. How do you do that? Meanwhile, I'm going to draw that on my iPad. Give it a try. The first question you want to ask yourself would be, how long should persons 2 be? Right? The answer should be quite obvious. Yeah, I'll just cancel the highlight. Might be easier for you to see this way. Of course, after today, I would suggest take this example here, bring another blank piece of paper, do it again. Right? You want to be able to practice them a few times to make sure you're really convinced how to do things like this. Okay, how about another 30 seconds for you? You can see the number of iterations for this for loop here. How many should it be? How many iterations should we run for this for loop? 3? Yes, because it's going to correspond to how long persons 1 is, right? So 3, yes, agree. So all you got to do is just figure out exactly what's going to be done in terms of the variable assignments for each iteration. That's what you're going to figure out, which I'm going to show you. All right, let me switch. Let's take a look. All right, so here, after this line over here, we're basically creating persons 2, and should be corresponding to the length of persons 1. So that's why I got 1, 2, 3, right? 3 slots over there. That was easy. And in the beginning, every slot points to null. And we know that this for loop here, is going to correspond to the length of persons 1. You can see persons 1, how long? 1, 2, and 3. So there should be 3 iterations. So what I will do is iteration number 1, iteration number 2, iteration number 3, right? When iteration number 1 in the beginning, I will be 0, like how we set it up, right? And also I is equal to 2. And once we increase I equal to 3, we're going to exit from the loop. So there's no 4th iteration. And what do we do in iteration number 1? Every iteration, we're basically executing this line over here. And between iterations, we have to change the loop counter I to be what it corresponds to, either 0 or 1 or 2. Right? Iteration number 1 is going to be, let me put it down, it's going to be persons 2 at index I, which will be 0, is assigned to persons 1 at index I, which is 0. Let's now focus on this line, because once you got that one, The other two will be quite straightforward. Now, let's take a look at this, right? It's not too bad. We're storing something into something else, right? Now, what we're doing is we're saying the following. We're copying whatever address that is stored in P1 at index 0, which is over here. Copy this address here into P2 at index 0, which is over here. That's what approach number 1. Approach number 2, we're basically saying P2 at index 0, rather than pointing to null, default value, rather than this, is going to point to wherever P1 0 is pointing to. So that means it's going to point to wherever P1 0 is pointing to. That's what we're doing. All good? Right? So after this, we're going to say this is going to be just like that. Similarly, for second iteration, P2 at index 1 would be P1 at index 1, right? What would that be? So P2, 1 is going to point to wherever P1, 1 is pointing to. So here, right? It's going to point to here. And final one, final iteration, P2 at index 2 is assigned to P1 at index 2. And that one you can verify. That one is just like that. Guys, I'll pause a little bit. Is there any point for this tracing up to now that's not clear to you? If you kind of follow the walkthrough, that's good. You may want to practice yourself again. You can also watch the recording. But if there's any part you simply don't quite get, it's time to ask. All right? Okay? All right, after this, we can do something fun. Okay? Oh, question, please. Yeah. It will not be the same. It's a very good question. The question was, let's say this. This part over here, let me try to, yeah, how about this? Guys, your classmate asked the following question. Let's say this one here, right? Where I just boxed. Basically from this line to this line over here. What if we have the following line? It's a very awesome question. I should mention to the afternoon session as well, to benefit them too. That's what you meant, right?
No, persons 2 meaning person 3, like make an array.
Make an array? Let me write down what you meant first. And then, were you saying persons 2, still a new array? Okay, sure. Person, and then, let's say 3, okay? And then P2 equals P1. Okay, it's the same. Okay, I got it. Okay, let me follow your way. Okay, sure, no problem. Let me write it properly, okay? So we're basically saying person P2 will be a new person array. Let me just say P, just to save my space. And then let's say 3. And then you want to say P2 is just assigned to P1. That's what you meant, right? Okay. Let's follow this first. Okay, so I'm running out of color, unfortunately, but I'll try. How about orange? This one and this one over here, right? What we're doing is we're replacing this block over here just by that. Are we going to result in the same diagram like over here? Any insight, any response before I tell you the answer? Let me repeat the question again. It's a very good one. Let's take this block over here and replaced by these two lines. The question is, are we going to have a different runtime structure over here than this? Anybody want to speak up before I point to you? Go ahead. Yeah, I agree. The first line there, we just create an empty array of size 3, and then?
And then you point to the array that you want to refer to. You abandon the empty array. It's still in your memory, you're just not pointing to it.
Yeah, okay. So we are not really, so P2 is no longer referring to a separate array, basically, right? Okay, good. Okay, let me visualize that. Good one. Let's go line by line. Okay, so the way to trace this would be, let me use the red over here, right? The first line over here, we're basically saying P2 is pointing to an array of size 3, 0, 1, 2. And they're simply just pointing to null in the beginning. Null and null. And how do we execute this line here? P2 is assigned to P1. Basically, you're saying that P2 is now going to point to wherever P1 is pointing to. We're not creating any new objects here. So P2, rather than pointing to over here, is now going to point to wherever P1 is pointing to. So are we really resulting in the same structure? Not really. Just before I take a question. The answer is, in the original block of code over here, we have one array and another separate array. After replacing these lines over here by just these two lines, we're basically saying P2 and P1, they are really referring to the same array over here. Right? Do you guys kind of follow? Okay, did you have a question? Yeah, go ahead.
So let's say in this example, we made P2 be, let's say, an array of size 5, and we filled up the array with...
Up to index 2?
Yeah.
Uh-huh.
Let's say we filled it up all 5 slots of it, and then we said P2 equal P1, and then we did P2.length. Will it still be 3?
Okay, I see what you mean. So, let's still take your classmates' 2 lines. That'll be maybe a little bit easier. Let me still take these 2 lines over here, right? Let's say right after this line. Okay, so now let's say my execution is over here. After executing this, if I say P2.length, what would that be? 0. Oh, sorry, beg your pardon. It would be 3 here. Because it's created using an array of size 3, right? Would be 3. Let's say after this line over here, right, after reassigning P2 to be P1. So after this, P2 and also P1, they're pointing to the same array. Now, what would be P2.length? Still 3. But you're referring to different arrays. You used to be referring to this one here of length 3, but now you're referring to this one here of length 3. So if I want, I can change this to be just 0, for example. Right? Why don't we do that? So let's say over here. If I say temporarily, if I put this to be 0, so P and then of size 0, for example, right? If I do that, so now length will just be 0. All right? And then after doing this reassignments, so now what will be P2.length? 3. All right? Guys, I know there's so much information over here, but that's something I would like you to really try to digest. So many things, I know. This will be 3. Okay? Any question here before I move on? Good? Yes, question. Go ahead.
So if you make the new array and then assign it to the previous array, would that allocate it, or you just...
No, you wouldn't allocate a new memory. So let me just have a new page. This example is so important. Even if I take the entire class, walking through just this example, it's worth it. Because I'm pretty sure you will need to know every detail before you come to the test. All right? Let me just say that again. If I say person, sorry, let's say P2 would be, let me just do from scratch. let's say person P1, which will be new person. Let's say 3 here. Let's say new person. Let's say 2 over here. How about that? It's a different example. All right, so now after this, after executing these 2 lines, if I say P1.length, obviously should be 3, right? If I say P2.length, it should be also 2. I shouldn't say also, sorry, it should be 2 instead, right? The way to visualize is like this. So P1 is pointing to this array over here of size 3. And P2 is pointing to another different array, different address of size 2. Right? And let's do some check over here. If I say P1 equals P2, what should that be? False. You can see from the diagram, they are referring to different array objects. Should be false, absolutely. But if I try, for example, P1 at index 0 equals, for example, P2 at index 1, what should that be? I heard false. Why would you think that's false? I'm doing equal comparison, right? I'm comparing whatever that is stored at index 0 in P1 with whatever that's stored in index 1 in P2. What's here? And what's here? Remember, we say that by default, null, right? So this at the point here, null, this will be null. When you say null is equal to null, true, right? Of course, if I store something else into it, you can also trace accordingly, right? That's basically the purpose of doing tracing explicitly. Okay, let me do more. Let's say after this, I'm going to do P1 equals P2. All right? And after this, I can do some checks. If I say P1 equals P2, what would that be? True, right? Basically, I'm saying that wherever P1 is pointing to right now, don't point there anymore, because I'm going to reassign. Point to wherever P2 is pointing to, which is here. So I'm going to say P1 not pointing to here anymore is going to point to over here. So that's why at this point, when you say, what's P1 equals P2? Well, it should be true, because they're pointing to the same objects. We call this aliasing. The same objects over here has 2 names, P1 and P2. Okay? Let me also write it down. So this is called aliasing. Multiple variables store the same address. Oh, you talk about triple equal sign. Is that what you're talking about? Double equal, we're comparing, right? If you only have a single equal, that means variable assignment. For triple equal, forget about it. There's no triple equal in Java. You might be confused with JavaScript. Please, forget about triple equal. Again, forget about triple equal. I cannot emphasize it enough. Question? Good question. The question was, before this reassignment over here, it's a very good question. I'm going to make it happen. Here, we say P1 is assigned to P2. We're basically saying P1 is now pointing to this array, right? Is it possible to let, for example, P2 to point to this original array? At the moment, it is not possible, because what used to be storing the starting address of this array here was only P1. Once you have already redirecting P1 to here, there's nobody else pointing to here, nobody. Somehow this array will be garbage collected, we said in Java. So if you really want to do this, it's possible. Okay, I'm going to open a new page. And then that should be good to conclude this example here. All right, let's do that. Before let me say, you want something to do with this? Go ahead, please.
So if you P1 equals P2, and the value of P1
It will change as well, yes. Let me answer this one first, and I'll go back to that. The question was, after this line over here, if I say this, after this line, okay? I might say P1 at index 0 is assigned to, I don't know, Jim. Assuming that Jim is somewhere, okay? How do we visualize this line? The way to visualize it is, let me put Jim into context. Let's say Jim at the moment is pointing to some person object somewhere. Right? I'm saying that P1 at index 0, rather than pointing to null, beg your pardon. Let me say it again. Because now P1 and P2, they are already pointing to the same objects, right? So that's what I should look at. So P1 at index 0 is referring to this. Now it should point to wherever Jim is pointing to. Now, your question was, after this, P1 at index 0 and P2 at index 0, are they both pointing to Jim? Indeed. You can see from the diagram, right? So after this line over here, right, if I try P1 at index 0 equals Jim, and also P2 at index 0 equals Jim, both of them should be true, right? Or if you like, you can even try P1 at index 0 equals P2 at index 0.
So if you add on to that, do P3, then P3 equals P1.
I would suggest if you want, you can add on a million more things. Then this lecture all the way until December, right? So I would say please give a try on the Eclipse, whatever you would like to add, and see how that works. If whatever you add doesn't make too much sense, drop by, and then I will take a look. Yeah, I just need to draw some temporary closure on this. Okay, sorry about that. Okay, thank you. And forget about my bad memory. What was your question again? What did I say I'm going to do, if you remember?
Can you make P1 go back to P1?
Yes, now I remember. Okay, if we do something like this, if I say P1 person array P1 would be, let me make it just more explicit. P2 right? Let's start with these. We might say something like this. P1 is, again, new person. I'll just make it 3. And also P2, also new person. Let's make it 2. After this, we're going to get P1 pointing to an array of size 3, 0, 1, 2. And P2 here pointing to an array of size 2, right? Everything is no surprise over here, okay? And what we said earlier, if I simply do P1 is assigned to P2, then what's going to happen is P1 is just going to point to here, and there will be no other variable storing the starting address of this array. So there will be no way to go back to this array. But if you want to go back, straightforward, you just make sure there's another name pointing to this array. So what I will do is like this. I will add another line here. I might say P3 is assigned to P1. All right? What it does is P3 is pointing to over here. Now, when I execute this line here, P1 itself is now going to point to P2. Right? So after this line, what's happening here is P3 is still pointing to this array here. But both P1 and P2, they are pointing to this array. So if we want to do what you just suggested, what we can do is, if I say P2 is assigned to P3, now P2, rather than pointing to here, is now going to point to this guy here. That's exactly what you were thinking, right? But we could not do it in the earlier setup because we don't have another name pointing to this array except for P1. So once P1 got reassigned to that, we lost track. But now if by introducing another one pointing to here, we are good. I could already think about so many questions over here for your written test number 1. Right? I'll make sure I also spend almost the same amount of time for the afternoon as well. So you guys have to make sure every detail I mentioned over here, you got it. All right? Guys, I don't mind spending longer on this. Is there any question you want to ask about here? I want to make sure you thoroughly understand.
So just
Yes.
the point.
Yes.
One still pointing to the array of 2.
That's correct. That's correct. So after, you can see after this line over here, so P2, when we redirect P2, we don't really impact P1. They're separate variables. We're copying address only. We're only copying address of P3 into P2. But we don't copy anything into P1 according to this line. We don't do that. So that's why it's unaffected.
So if we make any changes to P1, it will show only P1, not P2.
Yes, correct. So after this, whatever you do on this array is not going to impact P2 or P3 array anymore, right? Yeah. So in the test, I might just give you a piece of code, something like this. I might do some various reassignments. I may just put some intermediate points to ask you, what should be the states of the system right now for the runtime? That's what I would do. Exactly what is illustrated. Okay? All right, we still have to finish the very original example. I'll do that. But before that, is there anything you want me to explain? Well, as you can see, being able to draw is so crucial to understand what's going on. Just so important. Okay, let me go back. Well, everything will be made available to you, so please review. Okay, I think we got about 25 minutes. But we definitely can do something more than this. Okay, let me just finish the example for completeness. All right, I think we were discussing so many things about up to this line, right? And now let's talk about the remaining part, which is not too surprising. Okay, the remaining part, let's say, I would suggest this. Give me one moment. It might be a good timing. Okay, I think so. Because the diagram is pretty much busy. It will be hard to really draw on that again. How about this? All right, I'm going to reuse this diagram over here. How about that? Sorry, let me do something very quickly on the fly, if you don't mind. That's what we got. And what remains to be traced is starting from over here. Okay? And then what we have got so far is this. Let me just take that. Oops. That's good. I hope that's still visible, right? Okay. That's what we got. Okay. I can just make this slightly smaller, and then we are ready to finish the tracing. Okay. All right, so we got our 3-person objects over here. We got persons 1 pointing to here, here, here. We also got our persons 2 pointing to 0, 1, and also 2 over here, right? Have we traced already? Sorry, I forgot. We did that. Oh, let me do one more thing. Here, for, let me say this, for this for loop. Okay, let's do this one here. I think this is where I should continue. Okay? So we're going to get something like this. Just give me one moment just to make sure. Okay, just give me one moment. I got here 0, 1, 2, and also 0 will be mark. Okay. Sorry. I should be slightly more organized before today. I do apologize, but let me just clear it up, and then I will make sure I start in a way that's not going to cause any confusion. There we go. Right, just remember before that we talked about after the loop, right? This is what the loop we talk about, right? After that, what we should have is this. We got 0 here, and we got 1 here, and we got 2 over here. All right, that's good. Let's start from there. What's going to happen to this line? We say persons 1, 0 that set age to be 70. So which person are we referring to? Persons 1 at index 0 is referring to this object over here for Alan. Set the age to be 70. That's what we're doing. Okay? And then what's going to happen if you say, I want to say Jim.get age. Jim.get age should be 0, default. Alan.get age. Alan age has been changed, so that should be 70. Okay? What about persons 2 at index 0? Persons 2 at index 0 is referring to this object, Alan. Get age should be also 70. All good? Okay, just look at the diagram, assuming that you got the arrows right. It's so important to get it right. Let's move on. What about this line here? Persons 1 at index 0. Persons 1 over here at index 0. You want to set the age to be, oh, I beg your pardon. I just missed one line. There we go. This line here first. This one. We say persons 1 at index 0 over here. Reassign that to wherever Jim is pointing to. Right? Now what should we do? Rather than pointing to over here, it's now going to point to wherever Jim is pointing to. That's what it will do. So I'll put a star over here. This is what a star is going to do for you. Let me say it again. We want to assign this address over here into index 0 of persons 1. Persons 1 at index 0 currently is pointing to here. Don't point there anymore. Instead, point to wherever Jim is pointing to. So that's why we got this line here. Okay? And let's go to the next line. The next line, persons 1 at index 0, where should it be? Should it be Alan still? Should be who? Jim. All right? If you're following that, very good sign. Persons 1 at index 0 is now following this line over here, and then set the age to be 75. There we go. Okay? And now just do a final printout. What will be Jim.get age? 75. We just modified that. Alan.get age. Alan.get age, still 70. What about persons 2, 0? Persons 2, 0 is still pointing to this object here, dot age, 70. Right? So the overall picture about doing example like this, you gotta trace line by line. After each line, you want to make sure update the diagram accordingly, especially if you got any variable assignments for reference type variable. You gotta read the right arrows, right? Also, we talk about how you can do things involving the array. Okay. Question? Go ahead.
Before that, if we declare person 1 equal person 2, and we
Uh-huh.
person 2 will now add the point still.
You know, for that one, maybe I'll save that after class. That will be a specific, change. Maybe we'll talk about it, just to not to confuse everybody else. All right. Any questions related to how I trace this one? Anything you have doubts, confusion? All right, good. Everybody's happy. So this example is now done, and I really find it good. Like we spend the due amount of time for everybody to really understand, and you should really practice this as well. Okay, good. Let me see. Oh, one more remark, which I'd like to make. All right. This is basically what let's say this is a diagram, like a layout over here. Right? So let's say the specific layout we have is different objects over here, and we got different arrows over here, right? And let's talk about aliasing. And aliasing, what I defined was if you got the single address that is stored in multiple variables, that's basically aliasing, okay? And now specifically, we got many instances of aliasing over here. Let's talk about one. How many variables or expressions are storing the address of this particular person? How many? Tell me how many first, and then we'll enumerate them. Let me repeat the question. Aliasing means an object's address is copied into multiple variables. Now, how many places have we copied the address of this person object into? 2, 3. Any other answer? What's the easiest way to tell? All you got to make sure, of course, assuming that your diagram is drawn correctly, just want to see how many incoming arrows are into these objects. That's how you figure out. Okay? That's in principle the case. Okay? So now, let's now write them out. So number 1 will be Alan. Number 2 will be this one here. Number 3 will be this one here. All right? So number 1 will be Alan. Number 2 will be persons 1 at index 0, and also persons 2 at index 2. That means if you say Alan equals P1 0, it's going to be true. Another one, if you say P1 at index 0 equals P2 at index 2, is also going to give you true, for example, right? Because they're pointing to the same objects. Okay? All right? And exercise for you, right? I want you to enumerate all the paths to the Tom objects. All right, first of all, do you know how many paths should there be pointing to Tom? How many? Okay, exercise, right? All you got to do is apply what I said about this particular case. Now I'm talking about this object over here. All right, figure out the answer. If you're not too sure, speak to me. All right. Good. All right, we got about 15 minutes. I think we can do a little bit more. Guys, any question about aliasing? Important topic, and we will still have to visit back about this. Okay, so why don't we take a 2 minutes break so you can stretch your legs and refresh your mind a little bit. 2 minutes. Please don't go too far. And we'll resume in 2 minutes. All right, so we're done with this example here. And the next one, let's do something a little bit lighter. Actually, this one may not be so light, but I'll still do it. Okay, how about that? The next slide is about Java data types. If you recall, when we talked about Java data types 2 lectures ago, we talked about primitive versus reference. But now let's go a little bit further. So your attributes may be type. For example, here you can see, well, this will be an example we have to do on Thursday. I wouldn't be able to get to it today, but that's okay. So this is saying, in the person class, you may have an attribute, let's call spouse. Spouse is just another person. We'll do some fun expression on Thursday. Okay? This is just one example. And also, the method may take as parameter a reference to other objects. You have seen that also in part 2 of your lab 0. For example, we may have, let's say, under the person template, let's say a method called marry. We want to marry the current person into another person, right? So the parameter type can also be a reference type. And it can be just the same class, right? So these are some examples. I will elaborate a little bit further, maybe on Thursday. What I would like to go over with you now is this. Return value can also be a reference type. Let's do this one. Maybe that's it for today. So this one here is saying that whenever you're trying to define your return value, of course, JUnit tests should really give you some hints about what the return value should be. Of course, it may tell you that you may want to return a person, you may want to return an entry, or you may want to return a product, right? Let's consider this block of code, okay? Can you guys please spend just 1 minute staring at the definition for this particular code here? Apparently, we got 2 methods here, one here and one here. Right? And after reading through the definition, think in your mind, how am I supposed to call these 2 methods and manipulate the objects of type point? And point got X and Y attributes, right? Take a look at that, and then I'm going to switch to iPad and do one example with you. And a simple check for you. Which one should be accessor? Which one should be mutator? Just answer to yourself. That should be quite obvious, right? Okay, 20 seconds, and then we'll do one example, manipulating this template over here, just to see how things work. It will be also valuable to do. All right, 10 more seconds. All right, everybody had a stare, right? At least you have some familiarity with it. Let's now take a look at how we can use it. Okay, over here. All right, let me have a very quick reminder. So we have our point template or class. This is a mutator. This is an accessor, right? Just by looking at the return type. This mutator here is just by modifying the y value. Let's say I have a point over here. Let's say P1. If I say P1 move up, let's say by 2, I'm basically saying rather than here, it's going to move up to another little bit higher, right, conceptually. The same objects. And this one here is interesting. Well, I want you to pay attention to this. The return value over here is a reference type, meaning that we're going to return the address of some point objects, right? Let's write it down. Return value returns the address of some point objects. What it does is it declares some local variable MP, new points, do some modification on MP itself, and then return the address of MP. That's what it does. But we're going to trace it to see exactly how it works, right? But that's the overall picture. Okay. Let me now go to this block of code over here, which will use it. All right. Let's now trace line by line. Only a few lines to trace. Line number 1. Just before I do that, we're going to have P1 over here. We're going to have P2 over here, right? Okay. Basically, we got P1. Let me just conceptually, this is what's going to happen. We got P1 over here, which would be 2.5 minus 3.6. When I say here, P1 that move up, I'm calling the mutator. What it does is it's going to just modify this point directly. So you can think about conceptually, it's not going to be here anymore. It's just going to move up to P1, and then by 7.8, I believe it's 2.8, 4.2, something like that. But just move up. Okay. The line over here, we're calling this accessor, which will return another point. And basically, that one is going to be P2. So P2 is just going to be a brand new point. That one there is just going to be something like this, P2. Brand new point. It will be as if P1 has been moved up 2.5 by 6.4, 10.6, something like that, right? This is just a conceptual sketch, what's happening, but let's trace it together, all right? Let's now trace it together. Okay, let's now do it. I got 5 minutes. Let's see if we can do this. Should be possible. Line number 1. P1 is pointing to a new point over here. Each point has x and y. 2.5 minus 3.6. And the second line, P1 that move up. What's this? P1, context object, right? So P1 over here is the context objects. So we can step into the mutator that's being called. Every occurrence of this will be replaced by context object P1. And then the argument here is 7.8. That means the I parameter will be replaced by 7.8. 7.8. Right? That's what we did last time as well. And so P1.y is going to be incremented by 7.8. So if you do the math, 4.2, I believe. But you see the idea, right? That's mutator. So far, we are only manipulating P1 here. And let's now get to this point, this line. All right? Let's now consider, let's see it this way. P2 is a point object, P2. P2 is going to eventually point somewhere. Let's just set P2 aside, just for now. Let's worry about this expression here. P1 that moved up is calling this accessor over here. We know that eventually it's going to return the address of some points. All right? So we know that P1 here is going to return some point address. Let's now trace that one. All right? Calling this method here, P1 will be the this, right? The context objects. So let's trace this method here. Every occurrence of this will be replaced by P1. P1.x, P1.y over here. And then we actually got some local variable, MP. So MP, the local variable, is going to point to some point object as well. And its xy is just going to be a copy of P1.x, P1.y, P1.x, P1.y, right? So we're going to get 2.5 over here and 4.2. That's this first line. Okay? And what about this line here? We say MP, the context object, is going to be moved up by I. What's really I? I is the parameter over here, which is really corresponding to 6.4, right? When we call the method 6.4. 6.4, so this will be 6.4. Right? That one there, of course, you can also step into move up again. That's going to increment the value over here by 6.4. Right? Let's now do that. 6.4 will be 10.8, 10.6. Finally, return MP. Return the address of MP. I'll put a star, like an address. And this return value over here is going to be stored into P2. What does that mean? P2, rather than now, is now going to point to wherever this local variable is pointing to. So that's really what's happening. All right? And we do a final checks over here. P1 equals P2. This is a simple check. Is it true or false? Right? P1 here, P2 here, Apparently, they're pointing to different objects over here, right? Right, that should be false. So there are two things you want to watch out for this example here. Number one, it is very common to have the return value here of reference type. You might just return the address of some objects, number one. Number two, you want to know how to trace the code inside. Very likely, in the middle of the method, you might create a local variable which is just referred to some other objects. Once you return it, you want to know where to assign, for example, over here. Right? Just know how to trace it. All right, just in time. Thank you so much, and I'll be attending the lab tomorrow. Maybe I'll see you there. All right, be well.